Hello all, I am Dr. Pravas. In today's class, we'll discuss about the construction of ALR0 parsing table or ALR0 parser. We have already discussed about the theory and one examples in the previous classes. Means one examples of ALR0 parsing table or ALR0 parser in the previous class. So here we'll discuss about one more examples of ALR0 parser or ALR0 parsing table. See the example. Construct the ALR0 parsing table for the following grammar. The grammar is given for S2 open bracket S close bracket then S2 A. See here the next point is verify the grammar is ALR0 or not, and the next point is here verify the given grammar is ambiguous or unambiguous. Okay. So this is the given context-free grammar. This is the given context-free grammar. Now we'll add augmented grammar in this step grammar. Means what? S prime to what? S prime to S. So the augmented grammar is given like this. What? S prime to S, and just simply write this or simply copy this grammar. What? S to S and S to small a. Remember here non-terminal is only one non-terminal. This is called S. How many terminals are here? How many terminals are there? Terminal open bracket, close bracket, and A. Open bracket, close bracket, and A. So there are three terminals and one non-terminal. Non-terminal like S and three terminals open bracket, close bracket, and then A. Okay. Now we'll construct the ALR0 item. First we'll construct the ALR0 item. See. First S prime 2 dot S prime 2 dot S. Now we'll find the closure of S. The closure of S is this one and this one. So S2 open bracket S close bracket then S2 dot A. Okay, this is I0 state. The state is called I0. Okay, now see here there are three different variables S open bracket and A. So we'll explore S here, we'll explore open bracket here, we'll explore small a here. Okay, so ALR0 parser will scan this S. This S means what? S prime to S dot. So this is also called as the final state. So this is I1 state. Okay. Now the ALR0 parser will scan the open bracket. Open bracket means S2 dot S close bracket. So here now we'll find dot means the ALR0 parser will scan what S means we'll find the closure of S. So what is the closure of S? The closure of S is this one and this one. So S2 this one and S2 dot A. So this is I2 state. This state is called as I2. Now here the ALR0 parser will scan small a. So S2 A dot This state is called as I3 state. This state is called as I3. So here, I1 state is completed, I3 state is completed. Now we'll explore I2 state. So here different variables are S, open bracket, and A. S, open bracket, A. So S, see, S2, open bracket, S, then close bracket. So this state, this is one state. This state is called as I3, I4. This state is called as I4 state. Here, we'll scan open bracket. So S2, what? Open bracket. So dot S. Here, see. Now we'll find the closure of S. Now we'll find the closure of S. What is the closure of S? This production and this production. So S2, a dot, open bracket S, closure bracket, then S2 dot A. Just see. Okay. So just see, this state, and this state is completely similar. I2 state and this state. So that's why I'll just make it I2. Means this state and this state is completely similar. S2, open bracket, dot S, close bracket, S2 dot, open bracket, S, close bracket, like this. So that's why, means I2 state is repeated. Means I2 state is repeated. Okay. So now we'll find, now we'll scan here small a, means S2 A dot. Say this state is also repeated. This state is also repeated. Repeated means I3 state. Okay, simply write I3. Okay. Okay. So now we'll scan here. Now we'll scan close bracket. So S2 S, and this is the dot at the rightmost end. So this state is a new state. This is one new state. So that's why the name is here I5 state. Remember, here I2 state is repeated, so no need to explore. Here I3 state is repeated, so no need to explore. Here I5 state is completed, so no need to explore the DFA diagram. So stop here, because I5 here I5 state is completed. Here I2 state is repeated, and here I3 state is repeated. So stop here. Okay, no need to explain this DFA diagram. Okay, so the DFA diagram is complete. Now we'll construct the table. Now we'll construct the table. Now we'll construct the table. What is the table size? The table size is here. The number of states. The number of states are I0, I1, I2, I3, I4, I5. Means 6. How many terminals? Terminals, sorry, how many non-terminals? Non-terminals only 1. How many terminals? Open bracket, close bracket, and small a. So 3 terminals plus 1. So 6 into 5 equals to 30. So the table size is here 30. Okay. Now we'll construct the table. Here, this is I0 state, I1 state, I2 state, I3 state, I4 state, I5 state. This is open bracket, close bracket, A, dollar, then S. So this one is called go to action. Go to action means only S, and this action is called as the action state. Okay, up to this. Okay, this is called the action state. Now we'll fill the table. Okay, first we'll fill the go to action. So this is go to action, and this one is go to action. See, 0 read S goes to 1, 0 read S goes to 1. See here, 2 read S goes to 4. See here, 2 read S goes to 4, 2 read S goes to 5. I think there is no S, there is no S. Okay, so clear about the go to action? So clear about the go to action? Now we'll find the shift action. Shift action. Shift action. How many shift action? Oh, sorry. So how many shift action? Let's see. This is shift action. This is shift action. This one is shift action. This one is shift action, and this one is shift action. So 5 shift action. 0 read open bracket. 0 read open bracket goes to 2. So this is S2. Similarly, 0 read A. 0 read A goes to 0 read A goes to I3. 0 read A goes to I3 means S3. Clear? Okay, this one clear. Now 2 read open bracket goes to 2. 2 read open bracket goes to 2 means S2 state. 2 read A goes to 3. 2 read A goes to 3 means S3 state. Here 4 read close bracket goes to 5. 4 read close bracket goes to 5 means S5. Okay, 4 read open bracket. So shift action, okay, completed. Now we'll see the reduce action. Now we'll see the reduce action. Reduce action, just before going to the reduce action, just make number. Just make number. This is 1, this is 2. Okay. Let's see how many reduce actions are there. How many reduce actions are there? This one is one reduce action. There is no this one is one reduce action. This one is one reduce action. So there are 3 reduce actions. Okay. So in I3 state, just see in I3 state, one reduce action. I3 state, what is the number? S to A dot, the number is R2. I3 state, this is R2, 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 R2. Okay. I3 number, this is R2, R2, R2. Okay. Now we'll see. Okay, this reduce action clear, and this one. This one is a completed action. So in I3 state, this is a reduce action means R2. So already done. No need to write. This is one reduce action. In I5 state, one reduce action is there. In I5 state, so just see the number. Number is R1. Number is R1 means R1, 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 R1. Okay. Remember, this is I1. So I1 state. In I1 state is always accept action. I1 state is always accept action. Remember I1 dollar. This is called accept. I forget to write accept action in the previous class. In the previous class, I just forget to write the accept action means I12 dollar. Please don't mind. Okay, here I clarify. I12 is always accept action. I12 is always accept, or it may be error action, but here accept action. Why? So this grammar is, so this one is called as L0, L0 parser, or we can say L as the construction of L0 parsing table. So this is called as L0 parsing table. L0 parsing table. L0 parsing table. Okay. So now, what is the second question? Just see. The second question is verify the grammar is LR0 or not. Verify the grammar is LR0 or not. What is the definition of LR0? If there is no multiple entries, if there is no multiple entries in the table, so this grammar is called LR0. See, there is no multiple entries in the table. There is no multiple entries in the table, given table. So this grammar is LR0. This grammar is LR0. Since there is no multiple entries in the given table, so this grammar is LR0. What is the third question? The third question is here. Verify the given grammar. Verify the given grammar is ambiguous or unambiguous. Verify the given grammar is ambiguous or unambiguous. Since the grammar is LR0, since the grammar is LR0, so the grammar is also unambiguous grammar. So the grammar is also unambiguous grammar. Okay, so we have completed this question. Okay, remember one thing. In the previous class, I just forget to write the accept action in I12 $. Please don't mind. Please just write I12 is accept action. Okay, so the given grammar is LR0 and the given grammar is also unambiguous grammar. Okay, so in the next class we will also discuss about one more example of LR0 parsing. Okay, thanks for watching.